Welcome to Sundar's lecture. This is lecture number 30 and we are going to continue the introduction about AC circuits, right? So in the last class, we have started this basics about AC circuits, and in that we have compared what is DC and what is the AC with these two waveforms, and then we have discussed about what are all the advantages of the AC circuits, and we have gone for standard forms of AC circuits, and then we have seen basic terminologies related to the AC quantities, right? So I have told you in the last class itself. So we try to substitute what is the how this waveform is actually coming, right? So we try to substitute omega t values in the equation and we try to get these values, so that it will be easy to understand why this waveform, why we always draw this waveform like this. And we say the symbol for AC or sinusoidal waveforms are, see, I will draw here. See, symbol, we always draw the symbol like this. Symbol, we always try to give the symbol like this if it is a AC circuit, or if it is not an AC quantity or AC voltage or AC current, it may be a sinusoidal current, right? So we always give this. We try to get this waveform with the help of the equation we have seen already, right? So I try to take an expression. See, this is I should be equal to Im sine omega t, right? So we will take like this, or this omega t can be replaced with the theta. Try to understand here, theta and sine omega t and theta will be equal always, right? If I write sine omega t or if I write sine theta, both are same, right? So I am taking current here. Anyhow, we have seen voltage in the previous classes, but it can be a current or voltage, anything it may be, right? So I am taking I is equal to Im sine omega t. So let what we do now, let for our convenient, Im should be equal to 10, right? Im should be equal to 10 amperes, and right. So the equation will be now I is equal to 10 sine omega t. This is our equation now. So what we do now, we try to substitute the omega t values right now. So let omega t, I will draw this, I will take a tabular column. So wait. Okay, fine. You see, I have taken the values for every 45 degrees, right? So I have substituted omega t is equal to 0 degree at this expression, and I am getting for sine 0 degree, I will get 0, and 10 sine omega t will get that this value will be multiplied by 10, right? So I have taken it for from 0 degree to 360 degree for one cycle, right? So always 360 degree will give you one cycle. So we have taken the values, right? Now we have taken all the values here. So now we try to substitute all the values in the graph. So in the graph, I have taken 45 degree split ups in the x-axis, that is omega t or theta, and in the y-axis I have taken current, and current we are getting maximum is actually 10. So I have taken it for 10 with the split ups of 2.5. So we try to substitute the values now. So for 0 degree, I am getting it is 0, right? For 0 degree, I am getting 0. So I will mark down the points. For 0 degree, I am getting the value as 0. So this will come here. So this will be 0. And for 45 degree, I am getting 7.07, maybe around 7. So at 45 degree, it will be around here, right? So I will draw like this. So it will come like this, and then for 90 degree it has become 10. For 90 degree I am getting the value as 10. So for 90 degree I am getting the value as 10, and for 135 degree again it is 7.707. So I will get around here. So it will come here, and at 180 degree. At 180 degree it is 0, so I will get the point around here. So it will be here. So at 225 degree again it becomes minus 7.707, or it will be around at 275 degree, 225 degree. it is 7.5, so around here, so it will be here, and at 270 it has become -1, so minus 10, so it will come here, right? 270 degree, 270 degree, so it will come here, and at 315 degree, what is the value? It is -7.707, so it will come around here, so I will mark here, and at 360 degree again it becomes 0, so it will come here, so so this value is this one. So if I want to connect all these points, so what I will get? See, I am connecting all these points. uh, See, it is nicely coming, right? Nicely it is coming like a sine wave. See, this is how we are actually getting the sine wave. So this is the symbol of sine wave. That is why I have drawn this one. We always see a sine wave like this. Why? Because you see, if you take this expression, we can learn many things. See, what is the maximum value here? What is the maximum value? So I can write here itself I max, or it may be IM, anything it may be, the value will be 10 amperes, or minus I max at the negative, that will be minus 10 amperes, right? So minus 10 amperes, and this is how my waveform is coming. So it is the sine wave. So that is why I have repeatedly told you this is a sine wave, right? So now let us compare the DC with AC, right? We will take a new page. See, I am going to take a value now. So what is that value? You see, I am going to take I is equal to 5 amperes in DC. If I write like this, I is equal to 5 ampere, then it will be a DC current, right? So what I am going to do, so I will take this one, I, which is equal to 5 sine omega t. Will these two are equal? How can you relate these two expressions, right? This is AC and this is DC, right? So let me explain one thing. So if I give this 5 amperes to a resistor, let us we draw a diagram. See, I am going to give a DC source of 5 volt to a resistor. This is our circuit diagram, right? So this is how my circuit, maybe we will take 10 ohms for an example. R is equal to 10 ohms for an example, right? Sorry, I have written it wrongly. I want to give 5 amperes of current, right? So let me rough it. So I need to give 5 amperes of current, 5 amperes of current to this resistor. 5 amperes of current to this 10 ohms resistor. And what is the power loss? What is the power loss? Which means this resistor will dissipate heat, right? That is what we have learnt in the DC circuits. So what is that value? P is equal to I square into R, right? So what is that I square here? I is 5 square, that is 25 into 10, right? So 25 into 10 will give you what? P is equal to 250 watts. See, this is the value under DC, right? So let me tell you one thing. That means this resistor is giving out the heat energy about 250 watts. Okay, fine. You see, this 250 watts has been dissipated in the 10 ohms resistor. Now, what is my question? See, this DC, that means this 5 ampere DC, we know, right? So how it will be? So if I draw the diagram, so if this is the time axis and if this is the current axis, and what is my current, how my 5 amperes of current will looks like? It will be like this, right? This is 5 amperes. Throughout all the time, the magnitude will be same. But my question, so this 10 ohms resistor will always get this 5 amperes of current for all time, for every instant. But this is DC, right? This is DC. If this is a AC circuit now, AC source, if 5 amperes, that means this current I is equal to 5 sine omega t, what happens to this now? So if I draw the diagram, if I draw the graph, if this is the time axis and if this is the current axis, then it will be like this, right? Then it will be like this. So this is nothing but 5 amperes. Now it is very easy to ask a question, will this resistor, if for example, if I am giving this is DC, this is actually DC, if for example I am giving AC here, this 5 amps 5 sine omega t I am giving through to this resistor, at this point, at this instant, it is not getting 5 full amperes. Also at this instant, it is getting 0 amperes. So this resistor will not get 5 amperes throughout the time. So what is the power loss in the circuit now? Power loss in this resistor will not be 250 watts. It may vary. It may vary. So the point to be noted that DC current will not be same as AC current. So I'm going to write a thing you try to understand. If I DC is equal to 5 amperes, then I RMS is equal to 5 amperes. What is this RMS? Root means square value. That means if I want to know what is this resistor, what is the current in the resistor, then I have to take the average of this particular current value to get the power dissipated in the resistor. I cannot substitute directly this expression, right? So I need to get what is the average current. So that average current, the question again, the simple question, so why are you writing it as root mean square value, not an average value? Maybe I would have written like this, right? I would have written like this, I average is equal to 5 amperes. But I am not writing like this. I am not writing I average is equal to 5 amperes. So that this 5 amperes will go to this resistor, 10 ohms resistor, to get this 250 watts of power, or to dissipate the 250 watts power anyhow. But it has to be a root mean square value. So here comes what is average value, what is average value, what is average value and root mean square, that means RMS value. What is the difference between these two? So if you know what is the difference between these two, then it is very easy to understand what is the root mean square value in an AC circuit. And it has to be a root mean square value, not the average value. We never use average values in AC circuits. Everything will be root mean square value, right? That the difference between average value and root mean square value, we will take a common example in the next class, and we try to learn what is average value and root mean square value. Right? You go through this, and in this class we have seen this one, how this AC waveform we are getting for an expression, for a AC quantity expression, right? And we have concluded with what is the root mean square value and what is the average value. What is the difference, right? That we will see in the next class. Thank you.